Today I'm going to go a bit more in depth, actually a lot more in depth. Last time was very hands-on because I figured it was very important that you took that step and took your first dive into Git yourself. This day I'm going to be a lot faster with the demos. I'm not going to be able to keep up with everybody, but if you can't follow, don't fret it. I'm trying to make a screen recording. Hope this goes right the first take. So I'm recording my screen right now, and I will upload it to YouTube as soon as it is finished with encoding and perhaps a little bit of editing. So if you have the slides open, there's a link for the transcript. So if you have trouble following, that link takes you to a GitHub gist which has the transcript for everything I'm going to demo. So if somewhere along in a demo you want to follow, I hope the transcript will help you a little bit. If you can't follow, don't fret it. I'm hoping that, or I will try to put the videos online as soon as possible, and then you can watch it at your own pace if you want to. So I'm going to start with a small recap of what we did last time, just to reiterate some concepts. This is a PowerPoint. So we had a couple of main concepts last time. We have a working tree, which is our normal project files, which we are used to working with. Our working tree, we pick changes from the index with git add and git rm. We add them to the index or remove them from the index. The index is our staging area where we prepare things to commit them into the repository. The repository is our big database of all our history and all our objects and all the things that are Git. They are recorded in the repository. And we have seen that with git reset and today with git checkout, we can bring state from our repository into the working tree. We've done some git pushes and git fetches and fetch under the hood. I will come back to that later today. Git pulls as well. So I will come back to most of that, or I will use it again later today, just so you have some memory of what we did last time. So to start today, I'm gonna have to come on, yes, right window. So I'm gonna go back to the repository that we used last time, and I'm gonna fork it again. Please, as the page indicated, make sure that you've deleted your own fork from previous time. There. So I have my own fork here now. This is the same thing we did last time. I'm going to clone this in RStudio. So make sure, pick HTTPS, copy it. Now I'm going to go to RStudio, File, New Project, Version Control, Git, Repository URL. Make sure that you either delete any old clones you have locally or move them to a directory where it doesn't matter. Voila. So this is where we were last time. Small project, Git windows in RStudio, and now we're going in for the deep dive. Back to the slides. There we are. Okay. First novelty or new thing that I still want to tell you about is Git stash. I did not get to that last time. It's actually something that sort of stands alone. It's a small utility that Git offers. Now, many of the things that we're going to do today require that your working tree is clean. Namely, that there are no modified files in it, no uncommitted changes in the index and stuff like that. Git stash is a utility if you quickly want to switch branches and do all those operations that we're going to do today, and you need a clean working tree. Git stash allows you to take whatever is there and just stash it away, so you don't have to bother with it for a while. So to put your changes into the stash, you do git stash, and to unstash git stash pop. There's also some other commands. You can look into the help of git stash to read what they do, but this is just to this is a quick and dirty way to make sure that your working tree is clean before you do things like switching branches and stuff like that, or merging. It's also one of the things. So to go into the content of today, I'm gonna have to go over the model that Git uses under the hood. So up until now it was like very at the surface. Now we have to look at how Git actually represents things internally. And this is sort of what we have right now. The identifiers don't match with what you have, but the ideas are the same. You have a number of boxes. Each of those boxes is a commit. You know, we created incremental commits, and Git stores them differentially, and every time it points towards the parent. So you see here the arrow of time. Time goes into that direction. So this one was the first, this one is the second, third, fourth. Each commit points to the parent. So every commit has 0, 1 or 2, usually 1 parent it points to. And you can see this one has 1 parent, this one has 1 parent, this one has 1 parent. This one is the first commit in the repository, so it has no parents. So that's a unique situation where you have 0 parents. We've also lightly touched last time upon the name master, because I didn't want to go into branches last time, but master is a branch, right now probably the only branch that you have. And what is a branch? A branch is little more than a pointer to the last commit in the tree, in the structure. So actually it's the first if you look at the data structure. This one is the first, and then the next, and the next, and the next. So the last one is the first, which is why we call this a head. So think of a branch like a snake, and if a snake is going to bite you, you grab it by the head. So a branch is, yeah, remember it like that. A branch is like a snake, and the tip of the branch is the head of the branch. There is also, and this is very confusing, or well, somewhat confusing, there's also the head with capital H, A, and so on. The head, this one here. The head is a pointer towards either the head of a branch or something else, and we'll get into what something else is later. It's a pointer to what your working tree references. So the head is how, by manipulating the head, is how Git knows, like, this is supposed to be in the working tree, this is what is in the working tree right now. So when it sees a difference, when you are preparing to do a git add and then later a commit, it is actually comparing what is in the head versus what it sees on disk right now. So the head is an important concept that I didn't go into last time, but it's actually a pointer to what your working tree should represent. I've also tentatively shown here a little thing. It's a tag, sorry. A tag is a bit like a branch in that it points towards a specific commit, but a tag just points to a commit and is not a representation of the whole history behind it. It's just that one commit. So I'm first going to start with tags, and tags are really the easiest ones. So there's a command called git tag, seems logical, which lists all the tags. And there's two kinds of tags in there in Git. Actually, you can almost forget about the first one, the lightweight tags, and you should normally always use the annotated tags, which you create with git tag-a and a tag name, because annotated tags have authors, timestamps, and can contain messages like a commit. And annotated tags can be pushed to your remote, and lightweight tags cannot be pushed. Why did I put lightweight tags here? They're very useful if you start merging later on and you want to keep a certain commit, like I don't want to lose this part of my tree, you want to grab it at that point, you create a lightweight tag as a sort of a backup, like I can always go back to this point. So that's why I mentioned it. But usually annotated tags are created with this, and then you push them if you want towards the repository. For things like this is the version I sent to my client, this is what was used to create the final build that we then released. this is the version that I handed off to my colleague before I went on holiday. That sort of stuff. Tagging, awesome stuff. It's like documenting your history with extra information. The other major concept of today is branching. And branches, as I said, think of them as a snake. You have a head and you have the body behind it. There are good reasons for branching. Actually, branches are arguably the most important part of a version control system. They serve to facilitate parallel work streams, first and foremost. So if you're working on feature A, and then your boss comes in and he yells at you, we have a big bug in production and it needs to be fixed right now. Okay, you don't want to do that bug fixing code or whatever you want to do in the middle of doing your feature work you were doing in parallel. You switch to the stable version, you make your bug fix on that branch, and that allows you to do parallel work streams. Also, multiple people can have multiple branches so that they don't interact with each other until they agree, like, okay, let's get together. But we'll come to merging later. So this is actually the second bullet point. So you can delay publishing your work until ready. So for instance, in my company, it's the standard that the master branch should always run, should always compile, all tests should pass. Otherwise, it should not go on master. Now, where do I put it until it's ready to go on master? I put it on a branch. And the convention is that stuff it's on a branch, if it's on a branch and it's broken, don't yell. If somebody pushes something into, merges something into master and it's broken, then we yell at him and he usually has to pay around at the pub on Friday. So you can delay publishing or showing your work to colleagues by putting it on a branch until you're ready with it. And then finally, this is also sort of doing parallel work. So you can go back in time in your history, create a branch from that point, and then do something else. For instance, you've tried a given avenue and it's leading you nowhere in your work, and you say like, okay, I really need to go back to where I was 2 weeks ago and try something else. Go back in time, create a branch from that point, try something else in parallel. That's what branches are for. Now, some people say like, oh, I'm scared of branches, I don't want to use it. Well, tough luck. If you have a remote repository, you always have at least 2 branches, because the remote master and your master are 2 different branches, and you can actually manipulate and merge and do stuff with them right off the bat. So you always have at least a couple of branches that are in your repository. I'm going to demo all of this later, so format of today a little bit different. So I'm first going to lecture a little bit, and then I'm going to show it all to you in a real demo. So creating a branch and switching branches is done with git checkout. You can do that in RStudio, and I will show it to you later. What git checkout does is it updates the head, the pointer I told you, the pointer to what your working tree should point towards. It updates that to the branch you mention it. You tell it to switch to, and then it will also switch the contents of your working tree. So this is why git stash was important. If your working tree has modifications in it, git will refuse to undo or destroy your work. It says like, there's modifications here, I'm not touching that. But if there are no modifications compared to the head, then it will gladly change to the state that is represented by the thing you're trying to check out. I will demo in a little bit if that seems a little bit abstract. Git checkout tag or a commit. Somebody asked me like, okay, we created this history last time, but now how do I go back in time and take that point where the code was? Well, you do that with git checkout, and then you specify either a tag or a commit. A tag is just an alias for a commit, so both work fine. The thing is, when you're checking out a commit and not a branch, head can no longer point to capital H, the head of a real branch, and that is a state that is called a detached head. I will demo that at the end of the session, what happens there. But it will still switch your working tree. The only problem is with a detached head, it's a bit like a zombie. It stops moving. You can't commit anymore on a detached head. You have to reattach it. Luckily, this is IT, not surgery, so reattaching a head is not too much trouble. And there's git branch, which is to create a new branch from the current head. So if your working tree is in a given state, you have a head pointer, you want to create a branch from where head is pointing, you create a branch with git branch. You will see me doing this in one go in the demo with git checkout -b, new branch name, and then the tag commit or branch I want to check out. This is just like the 2 steps folded into one for brevity's sake. And it's how people usually do it, so that's why I'm showing it, not to obfuscate any details. So this is what it is going to look like after we are done, but perhaps I think it's better to show you the demo right now. So for the people who are following the transcript, I'm now going to demo 02 branching. So let me open RStudio. There it is. And actually, there's a little window here already that says master. That is actually your current branch. So we're not going to touch that right now, because creating a branch, I looked around, and in RStudio, sadly, there is no way to do it. So I'm going to open the shell. Let me open my window here. And I'm going to zoom this in a little bit so people can see it, because I think it did not remember the setting, the zoom setting from last time. Is this readable? Yeah, should be, yeah. Well, perhaps maximizing it is a bit overkill. Alright, so I'm going to show you that there's already branches there, as I mentioned. Git branch -a gives you a list of all your branches. And you see right now there's master. The star means this is where head is pointing. And you see that I have a remote head. It's a bit weird, but it's not important for you what the details are. But you can see here remote origin master, so it shows you the remote branches as well. So now I'm going to create a new branch and check it out, just from the point that I was right now. So I do git checkout -b test, and git helpfully says me that I switched to the new branch test because I did a checkout and -b creates a new branch at the same time. Let me switch to RStudio back, and you will see that this indicator says I'm now on branch test. So I'm going to make some edits. I'm going to open the child, because children, I'm going to give them a title. Save it. This is just so I have some changes to check in. Remember this from last time? I stage these changes, I commit them, give a commit message. There you go. Now when we look at the history, remember the little clock icon here? You can now see this is where master is. This is also where origin master, the remote master, is. And this is my test branch, and I'm one commit ahead of the master. Alright. So, suppose I want to go back to the master. I can just use this menu in RStudio to switch back to the master. Helpfully, RStudio says I switch to branch master, and it gives me some information on my up-to-date, on whether I'm up-to-date with my remote. So you see here the edit I've done is gone again, because on this branch it hasn't happened yet. So sometimes you need to refresh here, but now RStudio sees it by himself. So the files have been updated to reflect the state of the head, and the head is pointing right now to the master branch. Master branch did not have the changes that I made a second ago. Okay, editing the title was a silly thing. I'm gonna just remove it. This is of course me intentionally creating edits in the same place, just so I can show you a conflict later on. So I'm gonna do the same thing. I've removed the title. I'm committing it. Voila. So this commit was put onto master because head was pointing to master. The other time, my head was pointing towards the test branch, so a new commit gets added to the test branch, to the end of the test branch. So your head determines where new commits get placed, and if you're ever wondering where you are, where your head is, RStudio shows you the current branch. So if you now look into the history again, this will perhaps help you a little bit. Now, confusingly, or perhaps not confusingly, it's actually helpful because if you have hundreds of branches, it can get a little crowded. But it only shows you the current branch. So I'm gonna ask RStudio here in the history version to show me the history of all branches. And now you can see I have a test branch that goes off to the side, says give the children a title. And I have on my master commit, other me, split brain. Other me says I've removed those silly titles on the master. Okay, let's get back to the slides. So this is the situation then that you, or more or less the situation that you have. This is like our test branch, and we only had one commit, but it pointed towards the same parent as our master branch, who also had a commit that pointed towards this one. This one is blissfully unaware of how many children it has. Doesn't care. Git only only cares about what parent relations there are. So when you switch between branches, you can either pick this state, and this is the point of divergence. And the head switches around as we switch branches. Alright, now it's all fun and games to make a branch, to diverge our work, but hopefully at some point we're all going to bring it back together, right? There's nothing more fun than a good reunion. So merging is actually when two branches become one again. Parallel work streams, if you have many parallel things going on, in the end it just gets completely confusing. So hopefully you will merge your branches as time moves forward. And for that, there's just one command to do it. There's git merge. There's an important concept here that will come back in later slides. There's the notion of a fast forward commit. And for that, I'm gonna go over to the board for a second. Blackboard. Make a small drawing here. This is more or less the state we have here right now. We have one branch, we have a second branch here. If we want to create a commit that contains both branches, there's really no other way than to do this. Sorry. This is called a merge commit. A merge commit has two parents, and they point towards the tips of the two branches that were merged. Now, what is a fast forward? Suppose this didn't exist. Suppose this didn't exist. So I have only one, I have commits on one branch, and the other one was actually a superset of the other. If I want to merge these two, there's no reason for me to make a merge commit, because this actually contains everything already. So this is branch 1, this is branch 2, and if I want to merge them together, I can just do this. Say this is branch 1 and branch 2. This is called a fast forward. There's no need to create an actual merge, to create an actual merge commit. I just fast forward branch 1 to this end, and everybody is happy. The reason why this is important, I will show you later. but it helps avoiding, it's going to come back in merge conflicts later, and it's also, if you display this later in a history tree, you will see that this will be displayed as a nice linear thing. This kink is obviously just for drawing purposes. So it will give you a nice linear history, whereas if you had what was here before, you would have like this splitting and then this merging together. And if you have a very active repository, you will see the onion effect, where lots of splits and then splits around it and more splits around that, and in the end you will get like this onion with many different, you will get a very confusing history sometimes. So fast forward merges is a very important. Well, it's a good thing to know the distinction between the two. So yes, this is the part I told you. So merge commit is a new commit with two parents, with both also the changes of both parents in there. You can force one way or so if you'd like, you can force a merge commit there, even if normally the branch could be fast forwarded by saying no fast forward. Or if you are uncertain if you can fast forward and you just want to give it a try and fail if it can't fast forward, sometimes you want to do that. You can say fast forward only, and if it needs to make a merge commit, then it will just error out and tell you like, no, you can't fast forward this. You need to do something else, a rebase, which I will get in a minute or two. You need to do something else before you can fast forward this. Interestingly, or important actually, there are several different strategies that Git can use when merging several branches together. I've just mentioned the two most important ones. The default is recursive, which means if I have changes in column A and changes in column B, I will take together from A and B as far as I can, and then if there's really a place where they are exactly the same, I will give a conflict, and then a conflict is up to you to resolve. There's an option to resolve conflicts in favor of ours, which is the branch you're on right now, or theirs, which is the branch you're merging, just for resolving the conflicts. On the other hand, this is important if you want to say like one branch completely supersedes the other, and I don't want changes from A and B. I just want A, but I want to bring the history together. You can say the ours strategy -s ours, and wake up, my friend. And only one branch will have its history be brought into the merge commit. So not even non-conflicting changes are then taken from the other branch. This is sometimes useful if, for instance, you have had a development branch, you've had a development branch that you've done some work on, and then you see like, oh, but my master branch, it doesn't contain anything useful anymore. But yes, people still expect you, it's sort of a convention to have a master branch that is like the latest and best. So at that point you might decide like, okay, I want to merge my development branch into my master, but I only want to take the changes from the development branch because that is the good branch. The master branch, I actually want to trash it. So you can then merge it with ours. This is actually sometimes a necessary thing to do. Okay. That was merging, and I will demo it in a little bit. Another important tool for using Git, and this is actually where the really dangerous stuff starts. Rebasing is your main tool for editing your history. So we've made all these commits, we've made changes, and we've added them one after the other. Now, it would seem that after you've done that, history is immutable, right? You've done that, and now it's recorded forever. Not quite. Git allows you the option of taking what was there, taking your history, and changing it and moving it around. And rebasing is your main tool for that. Why do you want to do that? Well, there are many reasons. For instance, there might have been code that you do not want to see published in there. It might be embarrassing, or it might be really a secret, and it got added accidentally. Rebase, go back and change it, move it out. Or it might just be an issue of cleanliness. You've made a real mess with tiny commits, and every time you try to fix a bug, and you made like 20 little commits every time, trying out a different approach, deploying it, didn't work, and you made a real mess of your history. Rebasing is the way of cleaning it up. A standard rebase, I'm going to go back to the drawing board. a standard rebase, I can explain it to you with a lot of words, but it actually is this. It's nothing more or nothing less than this. Suppose this is your branch 1 and branch 2. This is branch 1, this is branch 2. And you're saying like, I want to rebase my branch 2 onto branch 1. All it does is this. It will remove, detach this part from the part where they originally split off. It will take those changes, put them somewhere aside for you, and then one by one it will reattach these changes from the branch you are rebasing onto the head of your target branch. So it used to be split off here, and now it will be attached right here. So what's the advantage? Now, if you see, if I now want to merge branch 1 into branch 2, or branch 2 into branch 1, I will be able to do a fast forward merge because now I have a nice linear history. So this is actually the main reason for rebasing. It's giving you this linear thing that you can then merge with a fast forward. So why would you do this? This goes a little bit into the workflows part at the end, but if you're using a workflow where you do your changes onto a branch, not directly onto master, and you're done with everything, and you say like, now I want to merge, but you don't want to have the onion that I talked about earlier, then you can rebase your local feature branch. Locally, you can do this all you want. And then before you merge it, and then you get this nice linear history, and you avoid the onion I spoke about earlier. This is a matter of personal taste or convention with your colleagues. I know some teams really hate that you do that, and other teams really hate that you don't do that. I've worked with both. So this is something you have to decide as a group or for yourself if you're alone. Like, this keeps your history like more readable, but it sort of violates what happened. And other people say like, no, you can't change recorded history, it's there forever, don't touch it. And then they say like, okay, you shouldn't do that and live with the ugliness in your history. It's what happened. So it's a matter of opinion. Be mindful of others. This is all nice and good when you do it locally with a local feature branch. If you do this with a remote branch, a branch that you've pushed and you rebase it, you rewrite history, people who have checked out or used that history that you are changing, is actually changing history. These are new commits that get created at the end. People have checked out one of those old ones, they will get mad at you because they can potentially lose work. At the very least, they will need to do some surgery to get back to working, to reattach their changes towards your branch. So with a local branch, yes. With a remote branch that you know, like this is my semi-private branch, okay, I will show you how to work around with a force push. But don't rebase a public master, especially not in a big project, or there will be a lynch mob at your door if you piss off enough people. So be careful with that, be mindful of others. The real power of Git, and I will demo this near the end, the real power of Git will be when you do an interactive rebase. This actually allows you to completely juggle your history. You can reorder them, you can drop commits, you can edit commits, you can take two commits and merge them together. You can take one commit that exists and pull it apart. You can basically do whatever you want with your history. Dangerous stuff, and I recommend you take a backup tag or a backup branch, or otherwise you might be sorry. This is where dragons sleep. Okay, so what do rebases and merges have in common? Both take changes from one point and apply them to another point, and those changes can conflict. This is usually the part where people new to version control start to panic. This is the part where yeah, people start shouting and like, oh, what happened to my work, and it doesn't compile anymore, and like, okay, take a deep breath, keep calm. Git will actually, when you merge things and there is a conflict, will actually print out a big block of text. First thing you need to do is, yes, read the instructions. I know nobody ever reads the instructions, but in this case, please read the instructions. Git tells you what to do. So it will tell you to open the files, edit the conflicts. So it says, I can't do this automatically. Please have a look and fix it. Help me, help me. And then you add the resolution to the index, and then either you rebase -- continue if you are rebasing, or you commit the result, which creates the merge commit if you are merging. Remember, if at any point you say like, this is getting too much for me, I want to do this with a specialist present, there is the git merge -- abort, which the help text will actually tell you about. Like, if you want to go back, just abort. There's a similar command for aborting a rebase. So if you want to get out of trouble, that's the place you need to look at. So for the people who are following, I'm now going to the third demo, which is the longest one, and that one goes about merging and conflicts. So you saw me do this in RStudio. And you saw me create these edits in a place that was intentionally troublesome. Just for demonstration purposes, let me get back and make so let me create another small piece of text, another small commit that does not conflict. Just creating a fake edit here, but it shows the intent. Okay. So now I want to merge branches, and unfortunately, just like creating a branch, so RStudio helps you with switching branches, but it doesn't help you merging branches, and it doesn't help you creating branches. So for that, this is the shell again. So now make sure, I think I'm on master, but let me check. So git status can also tell you where you are if you ever get lost. So it says I'm on branch master, so that's good. And now I'm going to merge the test branch. Bam! Okay, conflicts. So Git tells me the error message changes with different Git versions. Older versions might give more or less, and it also depends on the configuration on your system. I think my system is configured not to give too much verbose output. Yours may differ. So it tells me automatic merge failed, fix conflicts, and then commit the result. Okay, let me show you in RStudio. So what is the result of such a conflict? And here you see I have here, so this tells me head is where my local changes were, and this is empty because the change that comes in, the change that is coming from the the change that is coming from the branch that is merging is that from the master branch, sorry, the change from the master branch was that I had deleted that piece of text, and from the test branch I had, so it tells me this is from the test branch, I had edited the text rather than deleting it. So you can see here as well, child 2, you can right click on these, open file, and you see here in the status window, like RStudio knows that there's something wrong with these files. By contrast, this piece of text that does not conflict has gotten merged without trouble. So it doesn't complain about any of that. So don't think that this is the norm. This only happens when shit hits the fan. So I'm gonna show you to abort. So I had created this on master. See, on test, the piece of text that I just added a minute ago isn't there, and I'm just back where I started. Sometimes RStudio needs to refresh. So you see, the conflict is gone. No conflicts here. We are back out of the merge. We have undone everything that we had trouble with. Now I'm going to persist. Pretend that you have some help now looking over your shoulder, or just a fresh head and a nice cup of coffee. We're going to persist in merging, and I'm going to show you now something, and this is very useful because RStudio doesn't do this internally. Many IDEs, integrated development environments, have integrated tools for this. RStudio doesn't. I'm going to use git merge tool, which will give me a tool that will visually help me resolve these conflicts. There's an appendix at the end of the slides on how you configure a merge tool in Git yourself, because it isn't configured out of the box when you just install it. You need to install an extra program. You can choose between many. There's one slide at the end in the appendix of the deck that will tell you how to configure a merge tool. On my machine it's already done because I kind of use one every day. So I'm going to use git merge tool, and this opens up on my other desktop, of course. So let me, there's my cursor. There's my cursor. Let me show you the window that popped up there. So a merge tool gives you a visual representation like, look, this is what it was originally in the version where the branches diverged. This is what is coming from the one branch, and this is what is coming from the other branch. Here I had deleted it, here I had edited it. And I can then say, okay, you know what, the other me is right. It is a silly thing to add that title there. I'm just going to delete it. I've saved it, I close it, and now the second window open because there was a second file, and it gives me the same option. I'm going to say, up, away with it. Close it. And if I do git status right now, you will see untracked files. I will deal with them in a second, but if I show you the, I think already, voila. Just a sec. Did I already commit? Git status. So my own text that I was saying, like read what is there. So all conflicts are fixed, but you are still merging. So I should read the message myself. So I just need to type git commit to create the merge commit. Merge branch test. Yes, that's fine. Voila. The branch is merged, and this was what I was looking for. If I now go into the history in RStudio and I ask it to show all branches, you can see that the test branch is still here and it is still pointing towards it was pointing a second ago. But I now have a merge commit, like I demonstrated there, that brings both master and test, it changes from test together, and this is what I created in the merge tool. If you don't want to go all the way with the merge tool, as I said earlier, you can edit the changes by hand and add and commit like the text tells you. So if you don't want to use a merge tool, you can do it with RStudio, but it's so much easier to use a merge tool that I deeply recommend that you do that. Okay, so that allows me to demonstrate one more thing. So suppose I wanted to bring my test branch further. As you can see, my test branch doesn't contain the changes from master. Suppose I want to bring my test branch up to date with master. Well, if you look carefully, you can see that master is a superset of everything that is in test. So this should give me a fast forward commit. and not create an additional merge commit. And that's exactly what it does. So now instead of trying to merge them together and optionally present me with the conflict a second time, because it was still a conflict, it sees like, oh, you have resolved this conflict in the past. All history that I need to merge is actually one is a superset of the other. So I can fast forward, and it gives you a little summary of what was changed, and it prints out the text like fast forwarded. And what it only did was move that branch pointer from one branch to the end, to the tip of the master branch. If you look right now in the history, you can see this very clearly. Look, all branches. So both test and master are now up until this same point. This is not something you usually do. So if you merge a test branch into your master, there's actually no good reason anymore to keep it around. So final part of the demonstration is going to be to rid ourselves of that test branch. We no longer need it. We have merged all the changes. Why keep it around? Bye bye, branch test, and it is gone. And if I refresh in RStudio, you can see that the history is still there. The outline isn't changed, but what has been removed is the little label that points towards the head of the branch. So the branch is gone, but the history is still there because the history was merged. Git actually does a little check if you want to delete a branch, if all changes on that branch have been merged into the branch you're currently on, to prevent you from nuking your work accidentally. You can override that by using a capital D instead. You saw me use a lowercase d. If you say like, yeah, I'm really sure that I want this gone. But normally, after you merge a branch, you will delete it with lowercase d. And then it's gone. So I'm probably due for a demo. Or no, this was the demo. All right. Sorry if it goes a bit fast, but as I mentioned earlier, I'll make the video available and there will probably be time for Q&A at the end. So we've seen branches, we've seen merges. Now what is a pull request? And a pull request is something that is very often used for collaboration, especially with people outside your organization, but we use it internally even in our organization. What a pull request does is you don't merge your branch with your feature on locally. You take that branch and you push it to the remote. So origin, GitHub. You push it to the remote, and then you have online tools. They differ a little bit. GitHub is a little bit different than Bitbucket, is a little bit different than the others. But they all have online tools to offer your pull request. It's actually a bad name, pull request. It's actually a merge request. It asks you to merge changes. Because you're not going to do the merges yourself. You're going to offer them to somebody else, like, please merge my changes. They're always merged with no fast forward for the people who like linear history, so this is a bit of a downside. So it always makes a merge commit, and the reason for that is that documentation of the pull request is being put into into the merge commit, so it piggybacks on that. So you offer another developer or yourself, but usually another developer either in your team or outside of your team, you offer them to merge your changes, and the online tooling with GitHub and Bitbucket is such that he can either comment on it, like, please, I don't like what you did over there, otherwise it's fine, can you please revise that little part, can you please fix that little part, why did you do this? And then after a little bit of discussion, he will, or immediately if he says like, oh yeah, looks cool, he can choose to merge or not to merge and reject your pull request. So this is a very useful thing if, for instance, it's a developer from another company or an open source developer to offer your changes back to him. Now, we've done some things with remote branches the previous session. We did a git pull and we did a git push, the simplest ways. Now that we understand a little bit more about branches, I actually need to tell you what is going on underneath the hood. So you can see if things go wrong when pushing or pulling, that they're actually very similar to merging and rebasing. So if you practice those locally, you use the same tools for solving problems when you pull and you push. So there's a command underneath all of them, underneath both options that I will describe in a second ago. That is actually git fetch. Git fetch actually picks the changes from the remote, but does not touch your working tree. Previously, when we did a git pull, we fetched the changes and we also had them in our working tree. We did not fetch, we retrieved, because I'm using a word in two contexts now. We retrieved the changes from the remote and we applied them on our working tree. Git fetch just retrieves them and does nothing else. So what git pull actually really does underneath the hood is a git fetch, and then it does a git merge. It will merge your current branch from its tracking branch. And it might be a little bit painful, but remember back when we pushed, we said a -u, git push -u origin master. The -u actually says like, what I'm pushing right now is my tracking branch. So in this context, this is also why git pull works. The tracking branch is what it compares with, and then it will merge the two together. There's a second option that I actually prefer, especially when working alone, is git pull --rebase, and unfortunately RStudio does not offer you the option to do this one instead of the other one. So you need to shell for that. But personally, I'm always one who uses git pull --rebase. Why? Because it does two things. It does a git fetch, then it does a git rebase before it does a git merge. As I said earlier, if you rebase before you merge, you get a nice linear history. So if you had your own master and you made some changes there, and you have a colleague who pushed things onto the remote master, your changes on your local master get applied to the end of that, and then if you push, you get again a nice linear history, no onions there. Whereas if you have changes on your local master and your colleague has put things on the remote master, you will get a merge commit, because as I said, git pull will actually do a fetch and a merge. So you will get this little merge commit after you pull, and sometimes this surprises people. Like, what? How do I get a merge commit? It's because you actually merged two branches, one a remote and one a local branch. So this is a small utility. I'm just telling it to for the people who want to know. It's something that I often do when working on a feature branch. I might want to update my master, but I don't want to switch to master, pull, and then switch back to my other branch because I was working on that branch. So if you ever find yourself in that situation, this is a bit obscure, but it's actually very useful for workflows. You git fetch origin master :master, and what it says, like, origin master is the remote, master is the one locally. So this is actually git fetch doing a merge. It's actually doing a git pull on a branch that is other than your current branch. Don't fret if you don't understand this, but for the people who do understand this, this is actually a very useful part of a workflow later on. Git push, we did that the last time. There's a little bit more underneath the hood there as well that I didn't show you last time. Git push, the remote part, will actually do a sanity check on the things you are pushing. It will actually look at if it can fast forward. Sorry, again, there's the term again. It can fast forward the changes you're pushing into the branch that it already has. If it cannot fast forward that, it will fail. And why can it sometimes not fast forward that? If you've done a local rebase on a branch that you had already pushed once. Then if you push that branch again, you've rewritten history, and it says, like, I can't fast forward this. The history is completely different. Yeah, I rewritten it with Rebase. So it will fail, and then you, somebody in your team might tell you to force push. You need to have extreme care if you ever force push, because this again potentially destroys other people's commits if they already had changes on the remote branch. There's a slightly safer, or actually, yeah, a lot safer way to do this is, so if anybody ever tells you to force push, use force with lease, which is a newer option, which is why you might not find it on internet always when people recommend you to force push. Force with lease will actually check if the remote is in the same state as what you saw last time you pulled from it, so nobody has touched it while you were doing your thing, and it will not force push if somebody has touched the remote branch between this and the last time you pulled. This is to avoid destroying other people's work. So an important tip here. It's also very helpful if you ever force push that you not only use force with leash, but that you explicitly say which origin, which remote, and which branch you're pushing to, because in the past, one of my colleagues, still colleagues, for instance, he forgot that he was on master and he force pushed to master. It obliterated, I think, 10 man days of work, because there were 10 people working already for a day on that branch on master. So that was a big, and he got quite a bit of yelling to endure. So if you ever force push, specify clearly your branch, just to make sure that, to help yourself remember, like, okay, I'm pushing to the right branch, right? Yes, I'm doing the right thing. This is the recap. This is the slide, the diagram that you have on the paper in front of you. This is actually a recap of everything, or almost everything, that you need to remember from today. So you see here the repository model with its commits, one pointing towards the other, always going backwards in time. You see here that there are remote branches. There's info about remote branches in your repository. It's the green part here. This is not anywhere local yet, but it's only on origin. You see here a tag, and you see here a different branch, and the head is pointing towards that different branch, so that is what we are currently working on in our working tree. You also see that it's perfectly valid to have two branches pointing with their head towards that same commit. Our local master is pointing here, and the fixes 1.1 is also pointing here. It's perfectly valid. And you see that the real origin master, so the real remote, is being tracked by master. It's the same thing I've shown you with get branch -a. It was a lot of theory. I'm going to make it a lot more practical for you now. But first, I've got a very sore throat. All right. So, first I'm going to do is check out a specific commit. So if I go to RStudio, you will see that the commit that I want to check out, so it's 15.4d, it's actually this very first commit. I'm going to check out another commit that is not a head of a branch, because I told you earlier about detached heads and history and stuff like that. So Git will tell me, warn me, like, you are in a detached head state. You can look around, make experimental changes, but it's not recommended that you keep working on this. You need to reattach the head by creating a branch here. And actually, RStudio also will helpfully show you that you are in this state. Sorry, RStudio, there you are. So it will tell me, like, the head is detached and you are at that point in time. You see, the head is over here and all the other branches are over there. So this is an older version of my repository, and you can see that, for instance, these files that I deleted, these are actually output files, are still here because I went all the way back in time. So this is how you go back. Now I'm gonna create a new branch, because actually I think one of the conventions that especially on GitHub and on Bitbucket are useful is that a repository should have a README file. A README file which gives you a little bit of basic info on what is this repository, who made it, how do I use it, what is contained in it. So it's a good practice to contain a README file. So I'm going to add one. So I'm going to reattach my head by creating a branch. If you go to RStudio, you will see that my head is reattached. I'm now on the add a README branch. It no longer complains about a detached head. If I show all branches, you see that add a README the branch is over here. Okay. Back to my shell, or not. Okay, yeah. I'm actually gonna add a README. That's kind of what I was supposed to do. So let me say file, new text file. I'm gonna use Markdown format again. Sorry for people who don't know Markdown, but actually Markdown is used on GitHub as well. Plain Markdown, not Markdown with R. So this is sorry. Just a little bit of text. I'm gonna save it. This is a convention, readme.md. Voila. Gonna add this file, commit this file. Added a readme. There you go. And now I'm gonna push my branch. And just to show you how that is done, not with RStudio, I'm gonna do it again like this. Add a readme. And it will okay, so I've created a new branch, add a readme on the remote. This is what it says, new branch, add a readme. And I've set up my local add a readme branch to track the remote branch add a readme from origin. Alright, so that was not a very good readme, right? Should be a little bit more in it. I'm gonna go back here, add a little more. Description. This is a second level head. Voila. Because yeah, that first readme was a little bit bare bones. Going to the same motions again. And yeah, this is actually like a little bit embarrassing because I actually should have committed the longer version from the start. So people who are Git aware know that I can just use amend previous commit here, but I'm not going to do that just so I can show you a rebase. Amend is like a shortcut if you just want to do a quick rebase with a fix-up. So okay, I have two commits now in my history, RStudio history. Added readme and elaborate readme, and I don't like the fact that people see that I forgot a piece here, that I should have added this from the start. So I'm gonna go back and I'm gonna rebase and rewrite the history just so I can clean up my history a little bit. I'm gonna do rebase-i 15.4d. So -i gives me an interactive rebase. And interactive means that Git asks you like, what do you want to do? I'm gonna tell it, it gives me commands to give for each commit that I want to edit. So these are the two, edit the readme and elaborate readme. I'm gonna say like, this is actually a fix-up of the one before that. I'm gonna save that. And what a fix-up means is like, fix-up means like this one commit is like it should be melded into the previous commit, and it should be gone afterwards. So this is what happened actually. The elaborate readme is gone. It's just added a readme, and all the changes of those two commits have been added in this one new commit. So the two previous ones are gone, they are obliterated, and one new commit has actually been created with the contents of both. This is like what Rebase allows you to do. So there's a second problem. So if I'm gonna present this to my other self, then yeah, because I created this branch, like pretend I created this way back when the repository was only new, and if I'm going to offer this now and other me is going to merge this, then I'm going to have like this long split off and parallel history, and then a merge point is going to be a very big onion, and like, okay, I don't want to do that to other me. Let me add this commit to the end of the master. So I'm gonna rewrite history again, git rebase master, and git helpfully tells us like, okay, first I'm gonna rewind head to replay your work on top of it, and now it added a readme, so it reapplied the commit that was there. If you look at the history now, you will see that added readme was taken from all the way at the bottom, and now it's been added all the way at the end of the master branch. So it did the trick that I showed you there, like make it loose, add it over there. Okay, now I told you about problems with pushing. If we're gonna push now, oh, and I need to, there's a slide at the end of the deck that tells you about how to prevent you from re-entering credentials every time, because people asked about that as well. So if you're gonna use this, it's at the end of the slide deck. Okay, so I logged in, and yeah, okay, rejected. It says I cannot fast forward. And now in this case, the error message is a little bit weird, because if I'm gonna do git pull, it will do a merge, and actually I know that I've rewritten history, and I don't want to have one version of history merging with another version of history. That's just, yeah, that's a good way of breaking your universe, colliding two different histories. So it's a little bit unhelpful what it says right here, but I know, I remembered, I've rewritten history. I'm gonna have to do a force push. If that's the only way to do this. So I'm gonna push again, force with lease. Sorry. And specify my origin, specify my branch, just so that I don't accidentally push to master. Yes, I'm on the correct branch. Yes, I'm gonna push the right stuff. Now I'm gonna enter my credentials again. There it goes. And now you see that, okay, it is a force push. It has no choice but to accept it. Well, it had a choice. It would, as I said, it was with lease. So if the lease had expired, it would still not accepted it. But right now I have a forced update. It says so right here. So I did a push with a forced update. Again, RStudio, the little arrow only allows you to just push. So for this kind of shenanigans, you sort of need a shell. But hey, at least we got out of this. So if I'm gonna look into the history again, you will see that my remote, my origin add a readme, and my local add a readme are now at the same page, and they've all been pushed ahead of the master branch there. Now, last thing I want to demo for you is opening a pull request, because as I said, this is something that is pretty commonly done. So this is my demo account, and if you've pushed very recently, GitHub very helpfully will allow you to will remind you that, oh, you pushed this like less than a minute ago. So it will offer a button to compare and pull request. I'm not going to do that right now because that's a little bit the easy route. So I'm just going to go over and branches. Suppose it's a little bit older, and you say, okay, you'll get the same button right here, but I've checked out this branch. So compare and create a pull request. Okay, and here you see that you can pick your own repository, or so this would have been my own repository. So this is a pull request within my repository, but I can also compare across forks. I can pick, this is like the master from which we originally forked, the master branch there. This is my add a readme branch. Git intro workshop. You can have some more text, like this is for the other person who needs to accept your merge request, like I've done this and this and this for this reason, and please merge my pull request because of reasons. So you can keep it brief. People don't want to read like 10 pages there, but you can explain yourself over here, and then you can create a pull request. Done. And if I now go, this is like my demo account. If I go to my proper GitHub account, which is I think right here, yes, this is me, and I'm going into my own workshop here, I will see, oh, somebody has, so you see the one here, somebody has sent me a pull request. What has this nice other person done? Add a readme, what about that? And you will see the changes. So it will send you all the changes. So remember, we also rebased the master, so we also have the changes for master here. So all the changes that I've done here today are present in the pull request that I'm offering. So added the readme, but also with the titles stuff. So all these things I can look at the individual commits. I can see the files changed. I can say like, okay, what this person did I don't like, or I can comment on it. I can cancel my comment, and then in the end I can choose to approve the review, or I can outright merge it. But that's if somebody starts sending you pull requests, then yeah, you've passed the review. So pass the review. Merge it, and it's merged. And this is how you regularly collaborate with other people on the internet, or as I do with my colleagues. So I send a piece of code to them, and they can either accept it in their code base or not. Usually it's for knowledge sharing. So I'm gonna go through the last part. I've got 15 minutes left. So workflows. So we've seen a lot of concepts, we've done a lot of things, like how do we actually use this in a day-to-day manner. I've given you a couple of options. So if I'm working on a project on my own, I usually commit directly on master. I will pull with --rebase, because other me working on another laptop or on a machine, on my desktop or whatever, might have committed something. But that way I keep a nice linear history. It's just me, you know, and other me on another machine. So we sort of agree with each other. So we pull with Rebase and we commit directly on master. That's the easiest way to work. And if I want to do some experiment, or I want to go back in time and try something else, I will make a branch then and there, but usually I work directly on master. That's the easiest way to work. If it's just you, that's perfectly fine. What you tend to use as soon as you start a little bit of a team, or you're working a little bit more professional, is that you use what is called feature branches. So your master should be code that is good to go, like it runs, it compiles, it does what it do, hopefully without too many bugs. So the master is your code that is okay, and new development, you first do it in a new branch, and then when you're happy with the changes you made in that branch, you review. Optionally, you rebase if that's like the workflow you wanna have. Then you merge it to master, and you push your merged master upstream to your origin. That's like another way of working. It's what usually is done in teams. There's a third way, so I'm going into increasing complexity. The third way of working is what is called GitHub Flow. And this has actually not much to do with GitHub, guys. It's just a workflow that is promoted by them. Feel free to use GitHub Flow with Bitbucket or anything else. So same thing as feature branches. You do your new development on a new branch. You push that branch, you don't merge it, you push that branch to origin, you open a pull request like you saw me do, and you let the other you or the other person, depending on how schizophrenic you are, you let the other person do the merge. This is a little bit interesting perhaps for you guys, since you might want to collaborate outside your team, and also because you can't merge directly in RStudio, you need to drop to the shell. You can push your branch to your origin and then merge in GitHub. That's perfectly. There are many other options. I'm just mentioning Git Flow with many different branches, and then feature branching, basing of release branches, and then complex merge strategies about which order they need to be merged. I'm not going to go into them. You don't need them at this stage. Just be aware that there's many more complex scenarios possible, and you might encounter them one day. We've been doing a lot of work with RStudio. There are other options. I've listed them here. If you want to use something else than RStudio, for the people who do Python, PyCharm, which is based on IntelliJ from the JetBrains guys, is a full-blown Python IDE. You probably know it has excellent Git support. Pretty much every IDE has excellent Git support. If you want something standalone, I personally recommend Tortoise if you're on Windows, because it stays close together to the standard Git interface that you also have on the command line. There's also GitHub Desktop and SourceTree. They try to abstract it a little bit more. GitHub Desktop by hiding the complex things from you. SourceTree by actually giving you all the complex things and then stuff on top of that. So it depends. Power users, SourceTree and GitHub Desktop. Yeah, personally I'm more a fan of Tortoise, but feel free to try it out. Now, you're probably itching to start your own projects, and where are you going to host them? This is perhaps interesting for the people from Ghent University, which I think is pretty much everybody here today. So Ghent University has its own GitHub Enterprise instance. GitHub Enterprise is a hosted version, which means it runs on machines owned and maintained by Ghent University somewhere here in the building, I presume. So that means your code doesn't leave the confines of the university, which is from a confidentiality point of view always interesting. What's more interesting is that it's free for, so Ghent University is paying for a license for education and research purposes. If there are people who are using this like for contracting or in sort of like a startup, I don't think that falls under that license, and you need to contact the help desk or Dict to hash it out if your use is going to fall under the agreed license with GitHub to host your stuff there. But if you're doing research and or you're doing teaching, then it's perfectly fine. Push your stuff over there. You get free hosting, private repositories, all the features of GitHub Enterprise, and all you need is your current Ghent University login. So you don't even need a new account or a new password or something like that. So very much recommended for the people who are in that situation. If you're not in that situation, or you want to do something for your like at-home project, stuff like that, GitHub offers you unlimited free public repositories, but you have to pay if you want to hide things. Private work you need to pay for. Bitbucket allows you unlimited private repositories and public repositories, but you need to pay if you want to collaborate with more than 5 users. GitLab actually allows you unlimited users and unlimited private repos. You need to pay for support. So if you have a question to ask them, they will charge you for it. Important to know, perhaps, GitHub is the most mature and the oldest one, and still arguably the most popular one. GitLab is the most recent one, had some stability issues lately. I think they're back up again. They're the youngest one. So personally, all my at-home projects are on Bitbucket. I'm pretty happy with it. Not that I have